Today we're going to learn about surface area. Surface area is the sum of the area of all of the item's faces. And we're going to review to start. Your last lesson you learned some area formulas. You learned the area formula for a rectangle. You guys already knew, so we're going to go over that real quick. So the area for a rectangle you guys found was length times width. And along with that, you guys know the area of a square. So the area of a square is also length times width. Yesterday, or our previous lesson, you also learned the area of a cylinder, or a circle. That's why I should put a circle. You guys found that to be pi r squared. Today for our lesson, we're going to use these area formulas to learn how to incorporate them into being used in the surface area. So today we're going to use, to find surface area, you find surface area of three-dimensional objects. So not like this board is just flat, that's two-dimensional. Three-dimensional shape is something that has a length, a height, and a width. So it has three dimensions to it. Along with this, we have a height, a length, and a width also. We're going to learn how to find the surface area for a cube, a rectangular prism, and a cylinder today. So we're going to start with the surface area of a cube. So since we know, here's a cube, we put a cube together. Since we know that the surface area, the regular area of a square is about length times width, we're going to continue with that idea and use it to find the surface area. So if we take this apart, we can see that how many faces do we have on this?
6.
Good. And the surface and the area for a regular square is what?
Length times width.
Perfect. So do you have an idea of how we would add all those faces up to get into a formula?
Maybe multiply by 6 since they are all equal.
Perfect. So we're saying that a cube's surface area, 6, because there's 6 faces, as Ty saw, length times width. So we have our cube surface area formula right there. That's what it is. Alright, now we're going to move on and we're going to find the surface area formula for a rectangular prism. So we know that the rectangular area is length times width. But with this one, we're not going to have all the sides the same. So we're going to have to find out a different way to approach this. I'll first draw a little picture on the board so we can use that to help us. And then I'll let you look at this as we go through this. So again, how many faces do we have?
6.
Alright, so a rectangle has 6 faces, as you can see and you can see on here. One side, so let's start with one side. Let's start with the small rectangle. How many of those do you see?
2.
Okay, so there's 2. So right here we have the front and the back when they're together. So we're going to label that, we're going to label the bottom A, and we're going to label the height B. So we have 2 of those. So what's the area of that square, rectangle?
AB.
A times B. Alright. So we got 2 sides done. We still have 4 more. Let's start with the long side. How many sides of those do you see?
2.
Perfect. So we're gonna label this C. So what's our area for this rectangle?
B times C.
Perfect. And there's 2 of them, you said, right?
Mm-hmm.
2B times C. What's left? The top? Alright, so we already have the lengths for the top, so what do you, if we if you move A up here, it's the same length as the bottom, right? And on the side. So what is the area for this
A
rectangle?
times C.
Perfect. And there's two of them also. Okay. So we found all we have to do from there is add them together. So we're going to get 2a times b plus 2b times c plus 2a times c. And that's our surface area formula for a rectangular prism. Now we're going to move on to the surface area formula for a cylinder. Here's a cylinder. As shown before, something like a glue stick can also be a cylinder. We have already, this was our circle surface area. So as you can see, there's two circles on this. We're going to take this apart and we're going to try to understand this a little bit better. So we're going to take it apart. We're able to see the two circles. Along with the two circles, what do we have on the inside?
A rectangle.
Perfect. So, how do you think we're going to incorporate the two circles into the surface area formula?
You would multiply 2 times pi r squared.
Perfect. And then, what do we have left of the surface area that we have?
This rectangle.
Perfect. And how would we incorporate that?
I think you would find the circumference to be the length times the height.
Yes. And as we learned in our previous lesson with the area, we found our circumference equal to the pi